Paris Mountain State Park in Greenville, South Carolina. I'm Ranger Kathy Taylor. Welcome also to part 2 of our life cycling program. In part 1, we hiked to Mountain Creek and caught some little animals that live in the creek, knowing that the creek is mostly a nursery for animals to grow up, and they'll need a habitat, a good habitat, at all stages in their life cycle in order to grow up. In part 2, we're going to be measuring the temperature of the air and of the water, and we'll also measure how long some animals are in the creek. We know that temperature plays a part in how quickly the animals grow up here at Paris Mountain, and if we find some bigger than others of a certain species, we know that the bigger ones are older. So we'll be figuring out all about life cycles. We'll finish in part 3 later on in the park lab, where we'll put all this together to see what we know about the animal life cycles at Paris Mountain State Park. So let's get started measuring. Wow, look at all the animals we found in the creek. After they've been in the lab, I'll get them back to the creek where they belong. Well, scientists, it's time to get out of the water and grab our field sheets so that we'll be ready to do our measuring. We're going to be measuring the water temperature soon from the creek, so we're going to need a bucket of creek water. On our field sheet, our first task below name and date is to write down the air temperature today and the water temperature today. And you might notice that there's a C after the space for writing down the temperature, standing for Celsius. We're going to be measuring in Celsius instead of Fahrenheit. Why? Because scientists all over the world measure in Celsius for temperature. So what will we need to use to measure the temperature? We need a thermometer, don't we? And you might notice I'm holding mine at a round top. Why am I not holding it down here? Well, I don't want to measure my hand temperature, do I? I want to measure the actual air temperature and then the water temperature of water that we collected from Mountain Creek. So let's go ahead and take a look at this thermometer. Can you see a 10, a 20, a 30 on there? There we go. So what number does the red line go up closest to? We know that temperature is a measure of energy, and we say it's a way to measure how hot or cold something is. So do you see a red line going up? It rises as it warms up because heat causes items to expand, or it goes lower as it gets cooler because cold causes things to contract. So that red dye in there goes up to a certain number, and above the 10 there's some lines indicating 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20's there. Then there's lines for each one of those. 1, 2, 3, 4, and so on. So do you see what number that goes up to for the red line? If so, you can write that down under air temperature today. Now I want to ask you, do you predict that the air temperature will be warmer or cooler than the water temperature? So think about that, and let's go ahead and find out. Now I'm going to use a timer. I want to measure the temperature in the water. I want to give it at least a good 2 minutes. Why is that? Well, you know, if someone takes your temperature, usually it takes a little bit of time for the thermometer to read the temperature, depending on the kind of thermometer. And so I'm going to set it for a good 2 minutes as I place the thermometer into a bucket of creek water. We can think about temperature and its effect on the animals as they grow in the creek. Now, it does make a difference. We know that dragonfly nymphs around here might take 2 years to grow up. Way up north somewhere, they might take 5 years to grow up. What's the difference? Well, there's more cold days, right, up north, and the baby dragonflies won't go out and eat, won't start looking around in the creek for food to eat, little animals to eat, unless it's a comfortable temperature. In fact, each species of animal has just the perfect range of temperatures for getting out and about. I don't know if you have a perfect temperature for when you're hungriest, but that does make a difference for the animals in terms of how quickly they're growing. And a lot of them, like the dragonfly nymphs, a lot of them will not grow up and become an adult, that is, like emerge from the nymph stage to the adult stage with wings until it gets big enough, however long that takes. So now it kind of makes sense that up north it might take longer for them to grow up, doesn't it? Let me check the time. Okay. Okay, now we can say 8, 7, 6, count with me, 5, 4, 3, 2, 1. Gonna lift this up. Ooh, let's see what it went up to. You see? Is the red line now above the 20 or below the 20? And if it's below the 20 or above the 20, count the lines or sort of get an idea, like we know but halfway between the 10 and the 20 is 15, right? So figure out if it's 2 below the 20, that would make it 18. So write down the water temperature that you get based on where that red line went up to. Before we measure the length of the animals from the creek, let's measure some drawings of animals just for practice on your field sheet. We have a Dobsonfly larva. We caught one of those in the creek today, didn't we? And we have a dragonfly adult. And you might notice that underneath the picture, it says we're supposed to write how many centimeters long it is. Centimeters instead of inches. Why? Because scientists all over the world measure in centimeters, so we will too. So on the sheet, I'm going to hold this ruler in centimeters up to the picture of the Dobsonfly larva, and it's up to you to figure out which number it's closest to for the length. Is it closer to the 1, 2, 3, 4, 5, or 6 for a whole number? Whatever you decide it is, write that down below where it says centimeters. Write the number for the length of the Dobsonfly larva. Next we'll do the dragonfly. I'll again put our ruler next to the dragonfly, and you can decide if it's closer to 1, 2, 3, 4, 5, or 6 for the length of the dragonfly in centimeters. Do you have your answer? If so, you can write that down just below, oh, right here, for centimeters. Next, on our field sheet, we're asked to measure the length of an animal in a tray on the table, and also to draw a picture of that animal. And so we have 4 kinds of animals here. If you were here with me with the whole class, you would only be able to draw one of these animals and measure one of these kinds. But today, if you like, you can measure each with me and draw each of them also. So you can decide if you're going to actually do all 4 or not, but I'm going to, one by one, go through the 4 kinds of animals with you. So we already know about using our ruler. When we're measuring the actual animals, though, I won't place the ruler splat on the animal. I don't want to hurt it, so I'll hover the ruler above the animal. And the animals out of the ones that we got today that I'm using are stonefly nymphs, a dragonfly nymph, crayfish, and salamanders. Got some good animals to look at here. So I'll try to get us a little bit closer. Start with the stonefly nymph. We have 2 here. One's a little bigger than the other. Let me see here, starting with the 0, and we can count the tails if you want, but let's see what number in length this is closest to. Is it closer to 1, 2, 3, 4, 5, or 6? You can write that down. If you want to just abbreviate like ST for stonefly, you can write that down. And also draw in the space, that square below, you can draw this animal, noticing how many legs it has, how many tails it has. You might just do a quick drawing and then add some detail later if you like. Notice the hooked feet that it has. Okay, let's next get to another animal. How about one over here? He's being still at the moment, so I'm going to try to go for it. All right, so I have my hovering above him without touching him. And what number is it closest to? Smaller than the stonefly nymph. This dragonfly nymph. Is it closer to the 1, the 2, the 3, the 4, the 5, the 6? All right, have you come up with a number? If so, you can write the number down and maybe put DR for dragonfly. And also draw the dragonfly nymph, noting how many legs it has, the shape of its abdomen, the end of its body. Might be hard to see that it has some little eyes protruding there a little bit. But you can try to get a general drawing of this. And I will say this is the spike-tailed dragonfly, although it's probably named more for the adult. Okay, so we have the dragonfly nymph. Let's get to a different animal. Next, we'll try to measure one of these two crayfish. So, let's see. Okay, this is behaving for us. So, is it closer to the 1, the 2, the 3? And if it seems a little in between, figure out which whole number you want to go closest to with that. Let's see, I'm going to check since this one's being still for me. Or it was, I said it too soon. Okay, what do you think? Well, hopefully you have a number figured out. And the other task is to draw it. You can note the shape of its tail, sort of a fan tail. You can note, oh, it has a bunch of legs, doesn't it? 2 antennae. And it has those pincers, as they're called, that grasp. You're a salamander. And, all right, so I'm going to try putting this ruler down next to it. That was behaving pretty well for me. Thank you. And you can decide if it's closer to the 1, the 2, the 3, the 4 in length in centimeters for a whole number. And once you've decided that, you can write down that number and maybe write SAL for salamander. And then go ahead and draw the salamander as well, noting how many legs it has and the way its tail tapers off. I'm noticing some dark eyes, and I think some of that is like shaded dark coloring bigger, that makes the eyes look bigger than they are. This one's actually a little bit bigger than the other one, is it? No, it's not bigger. Okay. Hello. Next on our field sheet, we're asked to name the animals that we've been looking at. Or it says 1 if you just did one animal, but let's go ahead and look at all 4 of the kinds of animals that we just finished measuring and drawing from the creek. And so on this list of animals, can you find where it says stonefly? Starts with ST, goes STONEFLY. And if you found that word on here, stonefly, you can circle it. So how about dragonfly? Can you find dragonfly on there? DRAGONFLY. So find that word dragonfly that starts with DR. So for crayfish, do you see crayfish written down there? CRAYFISH. You can circle that if you found the word crayfish. And then what's left? Salamander. So you can look for salamander written down there, SALAMANDER, salamander. You can circle that. Where it says What is it? You can write each of those words down if you like right there, or just keep it at circling them, leave it at that. And then it asks finally, which life cycle stage is it in? Well, I was thinking since we're dealing with 4 animals, since we got to work with 4 kinds of animals today instead of just one, you could draw an arrow, say, from the nymphs or larvae or adults or juveniles, from the animal to the word that it goes with. And we're going to simplify it a little. For nymph and larva, that would only apply to insects in this case. So which of the 4 animals that we looked at are insects? Well, I'll tell you, the stonefly and the dragonfly are the only ones that are insects out of the 4. You probably knew that. So they're both nymphs. We don't have any larvae with us today, at least not for our measuring. So you can write, well, actually, not right. You can go where it says stonefly and draw an arrow down to the word nymph. Okay, stonefly, nymph. And same for dragonfly. Do an arrow down to nymph. And both the salamander and the crayfish are juveniles. So they're not adults yet. They're growing up, and we call them juveniles. So you can find crayfish and draw an arrow down to the word juvenile, and salamander and draw an arrow down to the word juvenile. So we did it. We've enjoyed our time at the creek today, but now it's time to get back up to the lab where I'll write down the temperatures we got for today for our records, and we'll look at the animals we found in the creek up close, get to know more about them and their life cycles. And then I'll get them back to the creek later on. So let's head to the lab. Let's go inside the lab next.